Hi everyone, I'm Towson from Stony Brook University. I'm happy to talk about our paper, Local Context-Aware Active Domain Adaptation. It's a journal with Zhongli and Haibin Li. In this paper, we solve active domain adaptation. We focus on two challenges, how to select informative target samples and how to effectively update the model using a small number of query data. Our motivation is to utilize the local context of query data and augment query data. With this, we propose a novel active selection criteria and a progressive augmentation module. In domain adaptation, we have source domain with plenty of label data and a target domain with unlabeled data and a few labeled data. There is a distribution shift. The task is to leverage the source domain to learn a good model of the target domain. Active domain adaptation is a special setting where you can actively select some target data and query that labeled. Then we can use source data, unlabeled target data, and labeled target data to train the model. In ADA, there are two key challenges: how to select most informative target samples, and how to exploit query data to effectively update models. Our motivation are for the two challenges. On one hand, we want to leverage the local context of query data as a guidance of active selection. On the other hand, we want to augment those query data to overcome issues from small labeling budgets. Our method mainly consists of the LAS module and the PA module. For the LAS module, we design a novel uncertainty measure called local inconsistency score. Compared with sample-wise score, our context-aware score utilizes local inconsistency with the model prediction on the target data and its neighboring samples. We also use the smoothing and clustering to reduce redundancy. Here shows the realization. In the figures, red means higher uncertainty and blue means lower uncertainty. We can show that uncertain samples tend to have large LI scores as they are more gathered. Also, the smoothing can remove outliers. For the PA module, our vision is that labeling bar is small and fine-tuning on only query data can be efficient. And even though query data can be class imbalanced, so we propose to progressively add confidence samples, and we propose the two variants, one with random selection and the other with local context aware selection. We also design class balance rejection to get a class balance uncle set and a strong image transformation for post augmentation. For the experiment, we use standard and label-shifted datasets. We follow an ADA setting in previous work. For the comparison, first we fix the model update method and compare AS with other active criteria, and then we compare our method's unified solution with other ADA works. Here shows the results on its own with 5% labeling budget. We can see that LAS achieves higher accuracies than other active selection criteria. We made some analysis by varying the labeling budget and combining with different domain adaptation methods. In all situations, our LAS criterion obtains the highest accuracies. And here shows the results on label-shifted datasets. Compared with the lambda that designed for this issue, our solutions achieve high accuracies. Then we manually increase the mean gap by adding random displacement to source data. We observe that LAA surpasses RA for large gap. It shows that local context is helpful for large gap. To make a conclusion, in this paper, we advocate to utilize local context of query data and propose a novel active selection criterion and a progressive on-code set augmentation module. More details can be found in the paper and code. Thanks.